What lies beyond the edge of the observable universe? Imagine climbing into the most advanced spacecraft humanity has ever built. Its engines never fail, its fuel never runs out, and it can travel forever. You point the ship toward the darkest region of space and begin your journey. For years, you pass stars, then galaxies, then enormous clusters of galaxies stretching across billions of light years. You keep going, farther than any human has ever imagined. Eventually, a question begins to haunt you. What happens if you never stop? Will you eventually reach the edge of the universe? Will there be a giant wall waiting in the darkness? A cliff overlooking nothingness? Or perhaps, there is no edge at all? This question has fascinated philosophers, astronomers, and physicists for centuries. Today, thanks to powerful observatories like the James Webb Space Telescope, we have a better understanding of our universe than ever before. Yet one of the greatest mysteries remains unanswered. What lies beyond the edge of the observable universe? To answer that question, we first need to understand something surprising. The observable universe is not the entire universe. It is only the part we are capable of seeing. Our universe is approximately 13.8 billion years old. At first glance, you might expect the observable universe to have a radius of 13.8 billion light-years. But it doesn't. Instead, its radius is about 46.5 billion light-years. How is that possible? The answer lies in one of the strangest discoveries in modern science. The universe itself is expanding. Imagine drawing two dots on the surface of a balloon. As the balloon inflates, the dots move farther apart. Not because they are moving across the surface, but because the surface itself is stretching. Space behaves in a similar way. While light has been traveling toward us for billions of years, the space between us and distant galaxies has continued to expand. As a result, those galaxies are now much farther away than the distance their light originally traveled. This is why the observable universe is so much larger than 13.8 billion light-years. But here comes the truly fascinating part. The observable universe has a boundary, not because the universe ends there, but because light beyond that distance has simply not had enough time to reach us since the Big Bang. Astronomers call this boundary the cosmic horizon. It is not a physical wall. It is not a barrier made of matter. It is simply the limit of what the speed of light allows us to observe. Imagine standing on a beach during a foggy morning. The horizon appears to be the end of the world, but you know the ocean continues far beyond what you can see. The observable universe is much like that horizon. Everything beyond it is hidden, not necessarily because it doesn't exist, but because its light has not reached us yet. So, what might exist beyond it? The simplest possibility is that more universe exists. If you could somehow travel beyond the cosmic horizon, you might discover more galaxies, more stars, more planets, perhaps the same cosmic web stretching endlessly in every direction. Many cosmologists believe this is the most likely scenario. From everything we can measure, the universe appears remarkably uniform on the largest scales. There is no evidence that conditions suddenly change just beyond what we can observe. But what if the universe doesn't simply continue? What if it is actually infinite? An infinite universe is difficult to imagine. Our brains evolved to understand finite things. Rooms have walls. Roads have endings. Oceans have shores. Infinity has none of these. In an infinite universe, galaxies could continue forever. There would be no center, no edge, no final destination. No matter how far you traveled, there would always be more space waiting ahead. Then there is one of the most astonishing ideas in modern cosmology, the multiverse. According to some theories of cosmic inflation, our universe might be only one bubble among countless others. Each bubble could be its own universe with different physical laws, different constants of nature, and perhaps entirely different forms of matter and energy. Some universes might contain no stars at all. Others could collapse almost instantly after forming. Some might be so different that atoms and life as we know it could never exist. Sounds like science fiction, but several respected cosmological models allow for this possibility. At the moment, however, There is no direct observational evidence that other universes exist. The multiverse remains an intriguing hypothesis rather than an established fact. Another possibility is even stranger. What if our universe is only a tiny region inside something vastly larger? Some physicists have suggested that the cosmos we observe could be part of a higher dimensional structure. Imagine a two-dimensional creature living on a sheet of paper. It would have no concept of up or down. A third dimension would be completely invisible to it. Likewise, our three-dimensional experience of space may reveal only a small part of reality. If additional dimensions exist, they could fundamentally change our understanding of the cosmos. Yet they remain hidden from everyday experience. Perhaps the most humbling realization is this: we may never know the full answer. Because the universe is expanding at an accelerating rate, some regions of space are receding from us faster than light can ever bridge. This doesn't violate Einstein's theory of relativity, because it is space itself that expands, not objects moving through space faster than light. The consequence is extraordinary. Some parts of the universe are permanently beyond our reach. No signal sent today will ever arrive there. No telescope we build will ever see them. Some mysteries may simply remain inaccessible forever. And perhaps that is what makes the universe so captivating. Every generation pushes the boundary of knowledge a little farther. Every new telescope reveals galaxies we never knew existed. Every discovery creates new questions. As our understanding grows, so does our awareness of how much remains unknown. Maybe the observable universe is only a tiny window into a cosmos that stretches far beyond imagination. Maybe countless universes exist beyond our own. Or maybe reality is stranger than any theory we have dared to propose. For now, we simply don't know. And perhaps that is the greatest lesson the universe has to offer. The farther we look into the cosmos, the more we realize that we are standing on the shore of an infinite ocean of mystery. The edge of the observable universe is not the end of everything. It is only the end of what we can see. Beyond it, the greatest adventure in science is still waiting to be discovered.